Alright, let's be honest, AI is everywhere. It's writing essays, making art, editing videos, and helping startups. But have you ever wondered what really going on behind it all? Like what's happening on the other side of your prompt? Because the truth of every AI reply, every image generated, every tool we use, it's powered by something massive, and no, it's not magic, it's hardware. And today I want you to take behind the scenes of AI into the world of chips, server, energy, and all the chaos. We'll also talk about how this boom is quietly impacting our planet and what we can actually do to save it. So grab your coffee because this video is gonna be eye-opening for you. Let's start with something that nobody sees. When we talk about AI, we think of smart modes, code, or maybe cool outputs. But none of them runs on thin air. It all depends on chips, silicon brains made by Nvidia, AMD, Intel, and now Google and Apple. Each chip and GPU handles thousands of parallel computations. That's what allows an AI model to learn from billions of data points. Now imagine thousands of these GPUs stacked together in a building like a football field. That's what we call data centers, where the real magic happens. When you generate one image using an AI tool, somewhere in the world a tiny fraction of one GPU in a massive warehouse just did the math for you. It's like a giant orchestra, except instead of violins and drums, it's processors and fans humming in a perfect rhythm. Silicon is the new oil. Now, here's where it gets interesting. The world is in the middle of chip war. GPUs are the new gold. Everyone from tech companies to government is fighting to secure them. Nvidia's latest chips are selling out faster than iPhones. Startups are hoarding GPUs for AI training, and entire countries like US and China are placing export bans, building fabs, and spending billions to control chip manufacturing. Chips are political now. A few companies and few places make most of the world's advanced processors. Taiwan, especially TCMS, produces the lion's share of the most advanced logical chips. And that concentration is what driving the global scramble for capacity. Countries are investing billions in fabs because whoever controls advanced chips controls a huge part of AI capabilities. It's not just tech, it's geopolitics now. Do you know that Nvidia and OpenAI announced a strategic partnership in 2025 to deploy at least 10 gigawatts of Nvidia system involving millions of GPUs and set to $100 billion of investment? This is why you hear about the semiconductor race and why Taiwan suddenly the center of the world's attention. Because 90% of the world advanced chips come from there. So yeah, when we say AI runs on data, that's true, but it also runs on power, silicon, and bit of politics. Now for the energy part, data centers are already a big electricity consumer and AI workloads are making them hungrier. The International Energy Agency projects that data center electricity demand could more than double by 2030. Every data center runs on massive electricity. Some centers use as much power as an entire city. When company trains large models like ChatGPT 4, Gemini, Grok, they are running thousands of GPU for weeks and sometimes for months. Researchers have been measuring the emissions from training large models. A landmark study from 2019 showed that training big NLP models can generate the equivalent CO2 of multiple cars over their lifetimes. And follow-up work shows the location, choices of hardware, and model design change that footprint drastically. They use millions of liters of water per year because if these machines overheat, the whole system goes down. According to Environment and Energy Study Institute, a medium-sized data center can use up to 110 million gallons of water per year for cooling purposes. Larger one can use up to 5 million gallons of water per day. AI may seem clean and digital, but behind the glow of our screens lies a network of servers with heavy environmental footprint. It's like we build a brain for the internet, but it's constantly hungry for electricity. Every image generated, every video created with AI adds a small but real environmental footprint. When millions of people do it daily, it adds up fast. Companies are noticing it too. For example, Google reported a major increase in emission tied to growing data center energy demand as AI use expands. In US, roughly 60% of electricity still comes from fossil fuels like coal, natural gas and oil, with renewable and nuclear making up the rest. In India, around 70% still come from the coal. In Europe, especially the Nordic countries are much cleaner thanks to hydro, wind and nuclear power. China, on the other hand, is heavily coal reliant. Well, apart from this, we are facing some problems like hardware waste. The hardware race moved so fast that GPUs and chip became outdated within months, adding tons of new e-waste to the planet. The data center heats up. Keeping these massive data centers cool eat up huge amount of electricity and millions of liters of water every year. The training obsession. Every company wants a smarter model which runs on retraining again and again, burning even more energy with each upgrade. And finally, the user boom. With every new startup, creator, and app jumping into AI, the demand for the computing power is exploding faster than ever. But it's not all doom and gloom. AI is actually helping to fix some of these issues too. For example, AI is optimizing energy grids, helping city manage power more efficiently. Data centers are now shifting towards renewable energy. Google, Microsoft and Amazon now aims for 100% renewable operations by 2030. AI power cooling systems are implemented which are reducing water use by predicting temperature drastically. And our researchers are finding smarter way to train models using smaller, efficient architecture and fine tuning instead of full training. Not only AI is energy hungry, the hardware is in high demand and short supply. Nvidia's advanced AI chips have been snapped up quickly, and suppliers like HBM memory makers have reported being sold out as demanded surge for AI accelerators. And now my favorite part. Some data centers now recycle their heat to warm up nearby homes. Crazy, right? Facebook Meta's data center reuses its waste heat to supply the local community through the district heating system, expected to deliver 100 megawatts of electricity annually, enough for 7,000 homes. Well, the point is that technology created the problem, but technology can also be the solution if we build it responsibly. Now let's talk about us. Because as a creator, AI user, or even just a curious peeper, we are part of this ecosystem too. And here's what we can do to save our environment. First, use AI tools mindfully. Don't spam and generate stuff just for the sake of your own good. Second, support companies that talk about sustainability. Third, be curious to ask, where does my AI tool run? What energy does it use? Fourth, and the most importantly, talk about it. Awareness is the power because the more people understand the cost of AI, the more pressure there is to make it greener. So, yeah, behind every smart chatbot, every realistic AI photo, every wow moment, there is an invisible world of power, chips, and chaos keeping it alive. AI isn't magic, it's machinery. It's a net of servers, silicon, and electricity all working 24/7. And that's okay as long as we don't ignore the cost. Because the goal isn't to stop the AI, the goal is to build it greener and smarter. The future of AI isn't just about making machines think, it's about making them think responsibly. If this video opened your eye, hit the like button and subscribe to Aadhunik AI, where we keep it real about how technology is shaping our world, one chip, one line of code, and one choice at a time. Well, this is Suraj from Aadhunik AI, signing out.